Hi, in this video we will learn about domain of a function and how we can find the domain of functions like polynomials, rational functions, and irrational functions. Okay, let us just start with what is the domain of a function. Domain of a function f is the set of all values of x at which f is defined. So gather all the numbers or all the elements that you can put as input for the function. Gather all these things. This is called the domain. And we denote it by dom of f. Well, we have to show in what is domain and how you denote such a set. Yeah. Okay. Well, specifically, we are concerned about functions that are defined by a formula on real numbers, and here at least three classes of such functions we will talk about, and then see how the domain of those functions, those classes are given and how we can find them. First class is a very basic and nice class, polynomials. What is a polynomial? This is a function, like let's call it px, which are of this form. So we have a constant times x to the power some positive integer. So n is a positive integer like 1, 2, 3. It can be actually 0, non-negative integer, positive integer. Then you multiply that to that x to the power n times an. Then another constant times 1 less power, and this goes up to a1x plus a0. So n is positive integer, and we have a0, a1 up to an some constants. So the operations you need to use to evaluate px at a point is that putting a number in a positive integer and then multiplying it by a constant and adding them. None of these operations have any restriction. So we can evaluate px at any real number x. What does that mean in terms of the domain? It means that domain include and it is equal to the set of all real numbers. So domain of a polynomial doesn't matter what are those constants, any of these things, just the form. If it is a polynomial, it is going to be the full real line. Sometimes you may write it as an interval form. That's the first class, the nice class. Then there is a second class called rational functions. What are rational functions? Well, these are functions of the form that you have f of x, which is quotient of two polynomials. P and Q are two polynomials. We already saw that the domain of the polynomial px is the whole real line. That means that we can plug in all real number we like on px. And for qx, you can plug in all numbers you like. So far, there's nothing that any restriction. But when you write p over q, you have to be careful that you cannot put a 0 in the denominator. 0 in the denominator is a big no. Meaning what? Meaning that we can evaluate f at all real numbers for which qx is non-zero. So all real number x for which qx is 0. If qx is 0, well, then we cannot define this ratio, this quotient. And, well, that's it. That's the line. That's the restriction. It's very important, and you have to always keep in mind. Denominator cannot be equal to 0. In terms of the domain, what it says is domain of a rational function is the whole real lines, but the points which makes the denominator 0. So q of x is 0. Or sometimes called roots of q or zeros of q. So find those ones and exclude from R. This means exclude. Exclude them from R. That's the domain for the rational function. And the third class of the functions which we are interested in is called irrational functions. Well, these are functions of the form f of x equals to root of some polynomial. It's called px is a polynomial. Well, again, so you can plug in any number you like for px. There is no problem of that. But what makes life miserable is that when you have nth root and n is an even number. So for n even, well, just square root itself or fourth root, sixth root, we cannot put negative numbers under the square root. Nth root of a negative number is not defined. What does it mean in terms of the polynomial or in terms of the domain? Domain of root n px is going to be the set of all points which give us positive values, well, non-negative values of px. So we have to find all real numbers. Let me make this all x real numbers, x here, real numbers for which px is positive. In other words, you have to find the sign table and fix all such points. In general, while all these things being said, is that there are two restrictions that we have to take into the account. One is no 0 in the denominator. The second one is no negative number under the even root. Well, under the third root or odd roots, there is no restriction. We are okay. It will be the whole real line. So let me just maybe add this one here. For an odd domain of nth root of polynomial, then there is no problem there. It is going to be the whole real line. Okay, let's just do a few examples and then we go from there. So example, find the domain. So I will include 3 examples here. One is f of x equals to x to the power 10 minus 5x plus 1. The second one is f of x is x plus 3 over x minus 1. And then the third example is f of x equals to root 2x minus 1. Okay, let's do this one. The first one is a polynomial. And well, when you're dealing with polynomials, there's no restriction on these operations. As a result, domain of f is equal to whole real line. This one, the second example, is a rational function. And well, when we deal with the rational function, or wherever you see a fraction or a quotient, you have to be careful about the denominator. So you have to make sure that the denominator is not 0. It means that we have to find points at which x minus 1 is non-zero. Well, this means that x cannot be 1. And as a result, the domain of this function is the whole real line, but the point 1. In other words, we have to go from negative infinity to 1, and then from 1 to positive infinity. That's the domain. Exclude 1, that's it. And the third example is an irrational function. And we know that for the irrational function, we have to make sure that the denominator is not negative. So we have to make sure that this is the case. So to solve an inequality like that, well, to have very consistent strategy, I would say always try to find the sign table. So sign table, to start with, you need to find at where this guy is 0. So this means that x is equal to half. So I have half here, negative infinity plus infinity. These are values for x. Value for 2x minus 1. Then you choose test values here. So I put 0 for this, 1 for that. And we know that at half, this is 0. Now, 2 times 0 plus minus 1 is negative 1. It is a negative value, so it means that the table of sign shows me here is negative. And 2 times 1 minus 1 is 1, so it is a positive number, so it shows that this part is going to be positive. This we are like to pick the part which is bigger than equal to 0. So it will include this piece, and we have to always see if are we interested in equal to 0 or not. Yes, we are interested. So this means that we can start from half and go up to plus infinity, including half. So the domain here of this function is 1 over 2 up to plus infinity. Okay, so we just started with the definition, and then we had these 3 important classes for which we said what should we do to find the domain, and 2 main restrictions that we have for the functions defined by a formula on real line. We have that one, and then we did some examples.